You are welcome to my class today. In our last class, we treated triangle of forces and Lami's theorem. That's when we were talking about three forces, three coplanar forces. But today, we shall be discussing polygon of forces. We talk about polygon of forces majorly when we have more than three forces and we can form a polygon with those forces. What are we trying to achieve today, or what's our objective? At the end of this lesson today, students will be able to solve problems relating to polygon of forces. Polygon of forces, as you can see on the screen. If a system is in equilibrium under the action of three or more coplanar forces, then the forces can be represented in magnitude and direction by the size of a polygon taken in order. The polygon, which is drawn to represent the system of forces, is called polygon of forces. All the forces we are talking about can be represented on the sides of a polygon. That's why we call it polygon of forces. Remember, while we treated three forces, we represented each of the force or each of the forces on the sides of triangle. But now, polygon of forces will basically be treating more than three forces. So that's why when we bring those forces together on the sides of a particular polygon, so we call them polygon of forces. Now let's look at what we have on our next slide. Now this diagram we are seeing represents system of four forces. There are four forces on this Cartesian plane. On this plane we are seeing on the screen, we have force P, we have a Q, we have force R, and we also have force S. Remember, we are treating equilibrium. All these four forces, P, Q, R, S, are in equilibrium. Okay, now representing these four forces could be represented on the sides of a polygon, and that is what we have here. This is actually a quadrilateral, so that's a polygon. This is a polygon of force, or polygon of forces represented the four forces on the plane there. Okay, now let's look at, they said in order. Look at our P. This is our P. Look at the direction. The direction of my P here is still the same thing with the direction I have on the plane here. Okay, good. That's the same, they go in the same direction. Check out the direction of my P at this point and the P here. Look at the direction. Good. Now let's look at our Q. The Q going that direction. So look at the same direction for Q, the same direction. Okay, following the same order as it is on the plane there. Look at my R going that order direction too. Look at the direction of R. Good. And also look at the direction of S. Okay, all of them, you notice they follow the same direction as it is on the Cartesian plane. So now that we have these forces represented on the sides of the diagram we have there, so we call it polygon. We call it what? Polygon of forces. We call it polygon of forces. Good. So this is a polygon of forces represented on that diagram. Good. Let's see what we have on our next slide. Now for any number of forces, K keeping a body in equilibrium, like the forces we saw now. Remember, we talked about this condition. These are this is a very important condition when we talk about equilibrium. Okay, the first condition of equilibrium still holds, and this is the condition we talked about. We said the summation of f of x is 0, the summation of f of y is 0. What does this mean? It means when I resolve all my forces to the horizontal axis, x is the horizontal axis, okay, the sum of all the forces must be equal to 0. That's what we discussed in our condition when we started translational equilibrium. It still holds here. Now the summation of all our forces, resolving all our forces to the vertical axis, that's why we have that y. When you sum them together, it must give you 0. For forces keeping a particular body in equilibrium. So summation f of x is equal to 0, summation f of y is equal to 0. That's why we have that. So that condition still holds. We are going to be applying it since we are still talking about equilibrium. Now let's quickly look at these examples. This example is a typical representation of polygon of forces. So in this question we have 5 forces. How many forces? We have 5 forces. 5 forces P, Q, P, 2, 5, Q, and 8. We're given 3 of the forces, the value of 3 of the forces, but P and Q are unknown. They are all in newtons. Acting on a body in direction 60 degrees, 45 degrees, 0 degrees, 300 degrees, and 180 degrees respectively are in equilibrium. Calculate, correct to 2 decimal places, the values of P and then Q. We're looking for P and Q. Good. Now, I want to quickly show us the sketch to that particular question. Remember, they talked about force P. They gave us force P is what? The direction is 30 degrees. We're given the direction of, okay, let me begin with force y. We're given direction of force y as what? 0 degrees. We are given that as 0 degrees. That's for our 5. If you look at the question, our 5 is 0 degrees. And you remember when you have you have this Cartesian plane here, for example, when we are talking about angles, we begin our angle always from the north side. It goes clockwise. How? It goes clockwise, okay? So 0 degrees begins from that point, okay? So we are going the same way. So our 0 degrees is on this point. That's 0 degrees. That's why we have 5 newtons there. Then our 2 newtons is said to be 45 degrees. 45 degrees from that point is going to be, this here is actually 45 degrees, okay, 45 degrees. The only thing we have there is just that the remaining parts here will be 45 degrees, since the whole of this quadrant is expected to be 90 degrees. So if it's 45 degrees from 0, then the remaining part 45 degrees. So we are trying to obtain all the angles, the direction of all those forces to the what? To the horizontal. So the remaining balance will be 45 degrees. Now the other one, we're given for P, the first one P, which is 60 degrees. 60 degrees. Now if you look at that diagram, if I have something like this for 60 degrees, if from your 0 here, this is 60 degrees. For P, what's the balance here? That's 30 degrees. That's why I have this 30 degrees to the horizontal. Okay, so taking them one by one, all the angles, don't forget we begin from where? From 0 degrees, and this is where 0 degrees begins, from the north. 0 degrees begins from the north, this is south, this is my east, and this is my west. Okay, so your 0 degrees will begin from your what? From your north. So the same thing we have done on this particular diagram. So I have 30 degrees. For my 5, I've said my 5 is 0. That's why we have it exactly on my y-axis. So that's 0. My Q is 300 degrees. Look at it. If I go 300 degrees, let me show us 300 degrees. 300 degrees begins from the north. 90, 90 up to that point gives me 270. If I exceed that quadrant a little, I have 300 degrees. Okay, that's 300 degrees. Now if I remove the 270 from 300 degrees, that place will become 30, and that's why I have this 30 there representing the 300 degrees. That's the direction of the cube. Okay, it's 300. From the 300 we obtain that 30 degrees when we remove 270 degrees from 300 degrees, so that we can obtain the angle to the what? To the horizontal, the direction of that force to the horizontal. Good. Now lastly, I have my 180 degrees. That's for 8 newtons in the question. 180 degrees. Of course, you know, if I begin from 0 here up to here, that's my 180 degrees. So that's why we have 8 newtons on the diagram that way. So if you are just giving the direction like that, don't forget you must always start from the what? From the north. Except you are specifically told that those angles are so degrees, or at a particular degrees to the horizontal. That is where you just use the angle that way. Okay, but if you are just giving the value of the angle and did not mention it is, or did not tell us that the direction of those forces are against to the vertical or horizontal, you always start from the north. Always start from where? From the north. Okay, good. Now this is the diagram that represents the question we are solving. Now the assignment we have now, we are going to resolve each of the forces. We have 3 forces to resolve. To the what? To the horizontal. I will resolve 2 newtons to the horizontal. I'm going to resolve P to the horizontal. I'll also resolve Q to the horizontal, so that I can get summation of what? F of x. That's the next thing we are going to do. Then I will also resolve the same forces I've circled in, or I will resolve them to my y-axis. So I will now have, I already have 2 forces, this and 8 newtons. They're already on the vertical axis. Okay, now I'm going to resolve the other 3 forces, Q, 2 and P. I'll resolve them to the what? To the vertical as well, so that we can obtain our summation of Fy. Good. So I'm going to have 5 vertical components or forces on my y-axis. So that's the next thing we want to look at now. Let's quickly look at that stage now. Okay. Let's look at this, the example 1. Let's look at summation of f of x. Okay, if I resolve the p to the horizontal, I have p cos 30 degrees. Of course, you know that, isn't it? If I resolve my p to the horizontal, I have p cos 30 degrees. That's this. If I resolve the 2 newtons, remember I have something like this. The 2 newtons has what? 45 degrees. So if I resolve that to the horizontal, I have this 2 cos 45 degrees. Then if I resolve my q, remember my q is this direction, that's q, and the angle I have here is 30 degrees. So if I resolve the force q to my horizontal axis, remember, because I'm resolving to this part of the plane, this part is negative, that's why I have minus q cos 30 degrees. Remember, the direction you are resolving to to determine the sign. Okay, so that is that. Now if you look at summation f of y here now, I told you I'm going to have 5 forces on my what? On my vertical axis. I already have 5 and 8. Leaving that 5 and 8, 5 is already, remember your 5 is this way, this is 5. That will be positive. My 8 is this way, that's why I have minus 8 in that equation. Then resolving my P, Q, and 2 to the vertical axis, I have P sine 30, I have 2 sine 45, and I have Q sine 45. So if I simplify what I have, simplifying what I have, I'm going to have this. Look at, if I simplify each of those forces that I have, or what I have done there, this is the result of summation f of x. Cos 30 degrees is 0.8660. That's simplifying this. Cos 45 degrees times 2 gives me this. Then cos 30 gives me 0.860. So I have this. So I've simplified summation f of x. Simplifying summation f of y, I'm going to have 5 minus 8 obviously gives me this minus 3 I'm seeing there. P sine 30 degrees, sine 30 is 0.5. So that's I have, that's P. And sine 45 degrees times 2 gives me this value. So I've simplified. And remember, since we are talking about equilibrium, this condition still hold. So we are going to equate, in our next slide, we equate this to 0 and we equate this to 0 so that we can solve. So we are going to have two simultaneous equations. So let's go further. Let's go further and see what we have. Now, this was the first equation, summation f of x. So this becomes my equation 1. This also becomes my equation 2. This is summation. This second equation 2 is the summation f of y. The first one is summation f of x. So I will solve the two equations simultaneously. We all know what simultaneous equation is all about. Okay. Now I'm multiplying through. We are using the coefficient of q now. I'm using the coefficient of q. Multiply 1 by 0.5 to multiply equation 1. We all know that. So we obtain equation 3. Multiply equation 2 by 0.8680. I have equation 4. Okay. Now if I add 3 and 4, if I add my equations 3 and 4, of course, this and this will give us 0. One is negative, one is positive. Okay. From there, if I add this value and this value, I have 0.866p. And if I simplify, if I have this minus this, I have this equation. So eventually making p subject of the formula. Okay, if I make p subject of the formula, then I'm going to have my answer. Okay, make p subject of the formula. So I have that answer 0.77 newtons. Remember, the question requires us to convert to where? To 2 decimal places, and that is why I have my answer at 0.77 newtons. Okay, now let's look at the other parts. Subtracting equation 3 from 4, we are going to have this answer. If I subtract equation 3 from 4, I'm going to have the answer you are seeing on the screen. So making q subject of the formula, if I bring this one to the other side, I have a positive. So making q subject of the formula, 2.08 divided by 0.866. So my q becomes 2.402. Becomes what? 2.402. The answer is actually supposed to be q equals to 2.40 newtons if we had to go by 2 decimal places, 0 2.40 newtons. Okay, so that's what our answer is supposed to be. I think with this we have done justice to the translational part of the equilibrium. Okay, remember I told you that we have two types of equilibrium when we started equilibrium. We have translational equilibrium and we also have rotational equilibrium. So this is the concluding part of translational equilibrium. In our next class, we are going to be talking about rotational equilibrium. Good. So this question is enough, is sufficient enough for us to know what polygon of forces is all about. We only brought about, it led us to use simultaneous equation that all of us are conversant with. Good. So basically what we have discussed in this class today is polygon of forces. For this example, the example that we treated, we talked about how many forces? 5 forces. We talk about 5 forces, resolving each of the forces to x-axis and resolving each of the forces to y-axis and equating each of the forces to 0, the sum of those forces to 0 on my x-axis and equating the sum of those forces to 0 on my y-axis. Okay, and we solve simultaneously. Thank you. Thank you for listening. Please make sure you attempt the quiz that is connected to this period 1. Thank you. Till we meet again in our next class.